We have a way of making oxygen on Mars, and we know that it works. I'm the deputy principal investigator on the MOXIE experiment, which is inside the Perseverance rover, which is now exploring Mars.
You know what? Imagine the red sands of Mars being as familiar to us as boarding a plane. Sounds like something out of a sci-fi movie, right? But what if I told you that scientists are already working to turn this wild idea into a reality? But why Mars? And more importantly, how on earth are we planning to make Mars habitable? Buckle up, because the journey to transforming Mars into our second home is packed with mysteries, mind-blowing science, and challenges that could either open a new frontier or leave us stranded in the depths of space. Before we dive in, don't forget to like and share this video, and subscribe to Kid Pillar for more exciting content. Let's dive in. Mars, the ancient water world. Billions of years ago, Mars was likely a very different planet. If alien explorers had visited our solar system around 4 billion years ago, they might have chosen Mars as the most promising candidate for life. At that time, Mars was a water world, with vast seas, rivers, and even waterfalls cascading over its rocky terrain. Life may have been in its earliest stages, evolving in its waters. The atmosphere was much thicker, capable of trapping heat, and the planet had a magnetic field that shielded it from harmful cosmic radiation. But this welcoming environment wasn't meant to last. About 3 billion years ago, Mars's magnetic field vanished, setting off a slow but inevitable decline. Without that protective shield, solar winds stripped away the atmosphere, leaving the surface dry and desolate. The oceans and rivers evaporated, and by the time life began on Earth, Mars had become a dead world. Today, it's a barren desert with an environment incredibly hostile to life. The challenges of colonizing Mars. Colonizing Mars presents challenges unlike anything humanity has ever faced. Mars's atmosphere is 96% carbon dioxide, with the remaining 4% made up of argon and nitrogen. Even just 10% carbon dioxide in the air is lethal to humans. That indicates Martian air not only unbreathable, but fatal. Even on Earth, in hostile environments like Antarctica, we've never tried to set up permanent settlements where the air itself is deadly. And the difficulties don't stop there. Mars's atmospheric pressure is less than 1% of Earth's, which means stepping outside without a spacesuit would cause your blood to boil due to the low pressure. Temperatures are equally extreme, with an average of minus 63 degrees Celsius and winter lows reaching minus 140 degrees Celsius. And even if one could survive these conditions, the lack of a magnetic field leaves Mars constantly bombarded by radiation, making long-term habitation risky. It's no wonder that a 2018 NASA study concluded that terraforming Mars is beyond our current capabilities. Yet the idea hasn't been entirely dismissed. Some believe that with future technological breakthroughs, Mars could be made hospitable for humans. Improving Martian soil, the first step. One of the first steps in making Mars livable would be improving its soil, known as regolith. For any Martian colony to be self-sustaining, it would need to grow food. But right now, growing crops on Mars is virtually impossible. Martian regolith is complex, lacking the essential nutrients plants need to grow, and it contains high levels of perchlorates, chemicals toxic to humans. To make matters worse, Martian water is highly salty, unsuitable for most crops. While hydroponics, growing plants without soil, using nutrient-rich water, might work on a small scale, scaling up to support a colony would require advancements in soil and water treatment. While scientists are already working on the solutions, in 2022, a team from Iowa State University proposed using cyanobacteria to desalinate water and improve the soil's nutrient content. Their idea is to grow crops like alfalfa in treated water, composting the plant material to enrich the soil for future crops. Meanwhile, researchers at the University of Bremen, Germany, are exploring how cyanobacteria could be used to grow nutrient-rich duckweed, which could also be composted to boost soil quality. Over time, these methods could transform Martian regolith into fertile soil. However, perchlorates remain a challenge. Since they're water-soluble, they could be removed during water extraction, or scientists might introduce anaerobic microbes that consume perchlorates, making the soil safer. Improving the soil is just one step. The next, and perhaps the most daunting, is restoring Mars's atmosphere. The need for a magnetic shield. Mars lost its atmosphere when its magnetic field disappeared billions of years ago. Without this shield, solar winds gradually stripped away the planet's air, leaving behind the thin, dry atmosphere we see today. If we could somehow reactivate Mars's magnetosphere, the atmosphere might begin to rebuild, thickening and warming over time. Although restarting a planetary magnetic field is far beyond our current technology, there is an alternative. In 2017, James Green, then director of NASA's Planetary Science Division, proposed a bold idea: placing a giant magnetic shield between Mars and the Sun. The concept involves positioning a large dipole, a closed electric circuit capable of generating a magnetic field, at Mars's L1 point, about 1.08 million kilometers from the planet. This dipole would create an artificial magnetic field strong enough to shield Mars from the solar wind. The idea is similar to how a parasol protects someone from the sun's rays, casting a protective shadow over the planet. If successful, this magnetic shield would prevent the solar wind from stripping away Mars's atmosphere, allowing it to thicken over time. As the atmosphere grows denser, pressure and temperatures would rise. Green estimates that such a shield could increase Mars's temperature by about 4 degrees Celsius, enough to start significant changes. Warmer temperatures could release carbon dioxide from Mars's polar ice caps, boosting the greenhouse effect and potentially melting the ice to restore ancient oceans. Even if oceans don't return, the denser atmosphere and higher temperatures would make Mars more hospitable, reducing the need for heavy protective gear and making long-term colonization more feasible. Innovative terraforming, using Martian resources. Samaneh Ansari, a graduate student at Northwestern University, and Edwin Kite, an associate professor at the University of Chicago, have proposed an innovative approach to terraforming. Their method uses Martian resources, avoiding the need to import materials from Earth. Incredibly, this approach is estimated to be 5,000 times more efficient than previous proposals. They suggest engineering nanoparticles, specifically into nanorods, from materials already found on Mars, like iron and aluminium. These nanorods would trap heat by absorbing thermal radiation and scattering sunlight back down to the surface, accelerating Mars's warming. Although the idea holds promise, there are still uncertainties. For example, how quickly would the particles cycle out of the atmosphere? Could warming Mars to produce rain introduce new challenges? Despite the promise, this innovative approach has its uncertainties. One central question is how quickly the engineered dust particles would cycle out of Mars' atmosphere. Additionally, if Mars were to warm up enough to produce rain due to condensation around these particles, the resulting changes could introduce new challenges. Understanding these dynamics will require further data collection from Mars and rigorous modeling to predict potential outcomes accurately. The challenges of human habitation on Mars. Even with these advancements, humans freely walking on Mars without protective gear is still a distant goal. Terraforming efforts are currently focused on making Mars suitable for microbes and crops rather than humans. Crops could slowly introduce oxygen into the atmosphere, but this process would take an exceptionally long time. To meet more immediate needs, NASA's MOXIE project, part of the Perseverance rover, has begun producing small amounts of oxygen from Mars's carbon dioxide-rich atmosphere.
MOXIE is making oxygen, pure and simple. The Mars atmosphere is about 96% carbon dioxide, so we can pull in the atmosphere and then we compress it and we put it into an electrolyzer where we split the carbon dioxide molecule and we pull out one of the oxygen atoms, and that's how MOXIE works. MOXIE is the first demonstration of living off the land of another planet.
However, this process would take a long time and does not address the immediate needs for human survival in the Martian landscape. Collaboration and ethics in terraforming Mars. Making Mars habitable will require collaboration between public space agencies like NASA and private companies such as SpaceX. These partnerships are vital to advancing research and testing terraforming concepts. Engaging the public through education and citizen science can also inspire the next generation of scientists and engineers. But as we consider transforming another planet, ethical questions arise. Could altering Mars impact any potential microbial life? Do we have the right to intervene in natural processes beyond Earth? Ensuring Mars's resources are used responsibly without repeating Earth's history of exploitation is essential. Despite the challenges, ongoing research offers hope. Scientists are continually exploring ways to make Mars more habitable, and their efforts bring us closer to the dream of a human presence on Mars. Though a trip to Mars may still be far off, the future looks promising and perhaps a bit warmer thanks to these groundbreaking efforts. So this is all about how we are trying to make Mars human and habitable. Are you excited to see that one day people will carry their luggage just to take a flight for Mars? Don't forget to share your thoughts in the comments. Do like and share the video. For more such educational videos, click the subscribe button on our channel Kid Pillar.